Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azharruddin bin Angsor, metric number DE190192. So I will explain about my PSM report for temperature monitoring and control for herb drying system. So before that, my supervisor is Dr. Rafidah Binti Ngadengon, and my panel is Dr. Rohaida Binti Akir, and panel number 2 is Dr. Noor Azizi bin Mardi. So without further ado, so for the project background is consumer interest in aromatic and therapeutic increase, drying system, and dehydration method. So for drying system is we use dehydration method, which is oven drying system. So for the problem statement is number one is use cost. In scope is to produce on a large scale. Second is no data about various herb on drying level. For example, we choose several types of herb that we can easy to find in Malaysia, and then we do the research about their temperature and humidity. And the third is uneven drying. No monitor to read the current temperature accurately. So meaning that we don't have LCD to display their current temperature and humidity. So, like example, like my project use cafe lime list. So the humidity is 55% until 60%. That's for maintain good quality of drying herb. Next is objective. Number one is to design low-cost monitoring and control system for drying process. Second is to collect data for system identification. Third is to control the system using PID controller and monitor the right temperature for drying herb. So this is my explanation before this. Okay, for the scope of project is number one is to help in the field of agriculture. Second is to ensure that the temperature is maintained during the process. And the third is secure the dried herb to be long lasting. So like example, drying herb can be long 1 to 3 years. So we need to secure the good quality dry herb more than 3 years or so on. So for methodology is this is a full process of at the left one is full process for my project. So we need to set up hardware, collect data, and do system modification to generate the mathematical value to do PID controller. And then the lastly is monitoring temperature and humidity. So this is the project flow diagram. This is the what I use in this project. So after complete the project flow diagram, this is the system flow chart for the project plot diagram. So this is the connection of circuit for my project. So let's see here. Number one is power supply here. Second is Arduino Mega 2560. This is Arduino Mega. Third is load cell amplifier. And fourth is load cell. This is the same as, but this is for weight. 5 is digital temperature and humidity sensor. So in this project, I only use 2 sensors, which is load cell and DHT22. So this is right here. Number 6 is real-time clock. Real-time clock for monitoring the time. So here. Open log data logger. Number 7, transceiver wireless module. Number 8, and number 9, external antenna. So this is external antenna. So proceed to expectation hardware design. So this design is actually from the related work that I study. So what improvement that I can do from here is increase time rate for desired temperature. Like for example, like for before that, the height for this project is about 50 cm, and the width is about 30. But this is the expectation, so I really don't know how to design it yet about the specific calculation. But yeah, I think this is what I will do. So move to the next is preliminary result. So this is chapter 4. For preliminary result is I use PID controller with LQR. So for the bottom is PID, and for at the top is LQR. So for these two is we compare the graph to see which more stable, which is more stable. So for PID, actually I use try and error method. So took a quite while to do this simulation. So this is the result that I get, PID with LQR. So for this yellow and red is actually the same for temperature set point. For temperature set point, I set at 27 and end at 60. So we can see here PID response overshoot at here about 5%, and the LQR response if LQR response is setting time at here, maintain the line. So move to the next part is this is for the PID simulating for the circuit before, which is for this circuit, and then simulate using Simulink, and then we get this graph. Same method with the PID, also put scope at LQR and then simulate, and then we get the graph for LQR Simulink. So for error response is we set the error at between PID and LQR. So we take value at here and at here, and then we compare the value. If we want to see the error for like this project, is the error is not very, what can say, not very bad, so the system can still be used. Okay, so beside the PID and LQR, I also use project simulation to test my DST22. As we can see here, this is the coding with the Arduino Uno, because the concept of Arduino Uno and the Arduino Mega is actually the same. So I use Arduino Uno because the pin that I use is not not many, so I use Arduino Uno. So you can see here, this is for the plus for temperature or humidity, and this is for minus. Now for this, RH is for humidity, and when we press again, it will go to Celsius for temperature, and then we can adjust the temperature and humidity to see if the program work or not. Second is project simulation real-time clock. So for real-time clock, actually the time at here I set with the same time at here to see if every second is the same. So for this, I observe about 5 minutes and see. So the time is the same. So the coding is true. So for conclusion is Many researchers have developed a new style of agriculture using height and new technology. The function of the project is to ensure that high quality product deliver. Many more improvement can be done in line with the technological development. So I think that's all from me. So thank you.